Here we go.
Good morning. My name is Curtis Sellers. I am the electrical instructor here at Central Louisiana Technical Community College, otherwise known as CLTCC. And I want to welcome everyone watching our video this morning. This is a electrical informational video. Really what we hope to be the first in a mini series of electrical videos that allows our students to have additional access to resources and additional access to maybe some videos that provide additional training that they can use as they go about learning the more finer details of being an electrician, maybe go about learning some of the technical concepts. And so with that being said, this first video is going to be more of an introductional video that's going to focus on electrical raceways, conduits, and conduit vendors. And so this is a project that our students here at CLTCC is currently working on. They're running conduit, they're bending conduit, they're learning the finer concepts of working with a conduit bender, a hand bender. And so this video is designed, or we hope it's designed to enhance that learning experience. And so probably a good place to begin, as I think about this being an introduction video, would be just to introduce some of the different types of metal raceways. Metal raceways are otherwise known as conduits. Generally speaking, run from box to box or from box to equipment, and it's the actual protective metal raceway that we use to pull our conductor screw that allows us to feed voltage, current, to energize and operate a motor or some other type of equipment. From an electrical standpoint, whether you're a commercial electrician, industrial, or perhaps even a residential electrician, there's three basic, or most common would be the right way to say it, three most common types of raceways that we work with as electricians. The first is known as RMC. That RMC stands for rigid metallic conduit. The second is IMC. That stands for intermediate metallic conduit. And then the one that we work with probably most common is known as EMT, electrical metallic conduit. And of course, it's the one, as we go through our series of videos and we demonstrate some of the bends, predominantly we'll be working with EMT. It is a thinner wall conduit and it's easier to bend, although it has more limits on where it can be installed depending on the environment. Of course, we get all of that information from the National Electric Code, and we probably won't cover a lot of that in this introductory video, but certainly as we go through this series, we'll also cover some of the installation requirements, some of the supporting and requirements that also go along with that conduit. And so that's your three most common type conduits or metal raceways that we use. Probably another thing I probably ought to do is perhaps also talk a little bit about anytime when we talk about metal raceways and we talk about having to change the direction, predominantly when we're using smaller conduit, 1/2 inch up to 1.25 inches, we use something known as a hand bender or a conduit bender. And so this is an example of that very thing, a conduit bender. You can see, perhaps the video will allow, but it shows that it is rated for 1/2 inch EMT. And so that is the type conduit that you would bend with this bender. This particular bender is made by Klein, indicated by the orange handle. Certainly there's other brands that are equally as good. Greenlee makes a green conduit bender, and Ideal makes a blue conduit bender. And certainly there are other quality conduit benders beyond the three that I named. This particular one has 4 components to it that we as electricians would need to learn how to use and understand. The first would be the hook. The hook is where we predominantly hook our conduit, regardless of whether it's EMT or some other type. And it's used predominantly whenever we're doing offsets and we're doing what we call a 90-degree or a stub. We'll just edit it, okay?
Right.
I'm gonna pick back up with the saddle. So the second component of the conduit bender would be this actual area here that allows us to change the radius of a piece of conduit. It is known actually as the shoe. I think earlier I had mistakenly called it the saddle. It's actually known as the shoe, and so please disregard previously calling it the saddle itself. It is called the shoe. The third component of it would be the heel, and of course the heel is used whenever you're bending a piece of conduit. What you would do is apply even pressure on the heel while applying that same pressure on the handle itself. And so it's a continuous even pressure used to bend and shape the conduit. And then lastly, or the last component of a bender is known as the handle itself. And of course, again, the idea is to place your foot on the heel and your hand on the bender handle itself, and you begin to evenly bend the conduit and change the direction that the conduit is running. And so those are some important introductory aspects of running different types of metal raceways and some of the components of bending that conduit as well. Some additional things that we would need to know from an introductory standpoint is some of the indications, if you will, or the marks that are actually on this conduit bender. And so whenever we're changing the direction of the conduit, we do that doing trigonometry type functions. In other words, we're changing the angle, we're changing the radius of a piece of conduit. And so how we're able to do that and do it in a proficient way and an accurate way is we have to know what the various bends are that we're wanting to make on a piece of conduit. All of those bends are actually located on the shoe of the bender itself. Predominantly, we use 5 different types or 5 different degrees of bend, I should say. You have the 10 degree, which is predominantly used for box offsets or smaller offsets, things of that nature. Your 20 or your 15, I should say, which is predominantly used again for box offsets or perhaps some small bends that we're just simply trying to get over an obstruction. You have your 22.5 degree bend, which predominantly we use again for offsets. We can also use those on certain 3-bend saddles that we'll talk about a little later. We have the 30-degree bend, which is kind of a favorite for most electricians for reasons that I'll explain to as we get further into the detail. But the math becomes very easy with a 30-degree bend, and so we'll talk more about that in a minute. And then we have our 45 and our 60, and again, those are predominantly used on 3-bend and 4-bend saddles. On the other side of the bender, we actually have what we call our multipliers. And I will actually go into that in the video in just a little bit. But I guess the one thing that I would want to draw your attention to is all of the information for the most part that you're going to need as an electrician, the multipliers, the bends, the various points that you have to line up with, the arrows, all of that is already on the bender itself. And so they've made this very easy for us. We've actually got charts on a lot of the different benders that has already done the math for us on some of our various bends. And so this is a very, very useful and easy to use device that is fairly simplistic in design, but can really allow us to run some really neat and professional looking metal raceways if done appropriately. And so a couple more things I want to bring to your attention before we talk about some of the bends. You will also notice I've talked about the degrees of bend, and I've talked about the multipliers on the other side of the conduit. but there's also a couple more marks that I'm just going to briefly go over, and then I'll demonstrate later in our videos. The first would be the arrow here at the hook. The arrow is usually a lining up point whenever we're bending an offset, or when we're bending a 90 or a stub 90. The star itself, which will be really hard to see perhaps on the video, but if you were looking at a bender, if you had it in your hand, you would notice a very clearly stamped star. That star represents the actual center, if you will, of a 90-degree bend. And so if we were bending back-to-back 90-degree bends, we would actually use that star. And then lastly, there's a notch on the actual shoe of the bender. That notch is called the rim notch, and that rim notch is actually the center of a 45-degree bend. And if we were bending 3-bend saddles or perhaps some compound 90s, we would use our rim notch. And so those are just some basic introductory markings and the actual description of what a conduit bender is that we'll go into more detail as we begin to prepare to learn to do some of these bends. You've heard me reference the bends that we'll make as we go through our video. There's 4 predominant bends that we'll use as electricians that we as electricians need to become familiar with. The first is what is known as a stub 90 or a 90-degree bend. And of course, a 90-degree bend would simply be something of this nature. If you can follow along in the video, we want to change the direction of the conduit by bending a stub 90. And of course, this would be an example of what a stub 90 looks like. And so we're simply bending the pipe in a 90-degree radius, changing the direction. It's one of our easier bends. There is some calculation that goes into it, but it's a very easy bend, and it's one of our more common bends that we will use in the field. The second type of bend that we will need to become very familiar with is what we call an offset. An offset is simply when we have a piece of conduit running along a surface and we need to change direction. We need to get up and over an obstruction. We need to change the direction maybe because we're trying to get over, like I said, an obstruction or something along those lines. And so an offset simply changes direction, in this case up, and then it allows us to continue running parallel. And so this is an offset, what an offset looks like, and of course we will learn how to do that as well in a later video. And then the other 2 types of bends that we'll predominantly need to become familiar with is called a 3-bend saddle and a 4-bend saddle. A 3-bend saddle is a type of bend that allows us simply to jump over an obstruction and return back to the same plane in which we were traveling. And so if you can envision, there's an obstruction located here. Perhaps it's 2, maybe 3 inches in height. A 3-bend saddle allows us to run up to that obstruction, go up and over, and return back to that same plane. Predominantly, as I've drawn the picture, a 3-bend saddle is used when you have a circular or a more round type obstruction. The other type of saddle is known as a 4-bend saddle. And a 4-bend saddle is predominantly used when you have a square type obstruction that you're trying to get over, or maybe it's rectangular, but it's not round. And so if you were to try to use a 4-bend saddle where you really needed a 3-bend saddle, you could get away with it. You would still get up and over the obstruction, but it wouldn't have that neat appearance, that professional appearance that we want to present as electricians. And so predominantly your 3-bend, this is known as a 3, and this is known as a 4. The 3-bend saddle is used for round obstruction again, and then your 4-bend saddle is used for a more square or rectangular type obstruction. And so again, those are all bends that you as an electrician would need to become familiar with and certainly be capable of performing in the field in an industrial type setting. And so in conclusion, probably a great way to end this first introduction video would be to talk about some of the trigonometry associated with these various bends. And so probably one of the first things that I would want you to become aware of is anytime we change the direction of a raceway greater than 90 degrees, we're always going to have what we call a gain. And what we mean by that is we're going to have a gain on the working end of our conduit that's equivalent to the loss on the end away from where we're bending. And I'll go into more detail on that at a later time. But just remember, anytime we're bending greater than 90 or greater, we will have a gain. Now the opposite is true. Anytime we're bending less than 90 degrees, we will always have what we call a shrinkage. And so both of those can be easily calculated, and that's one of the things that we will learn to do as we go through and make these various bends. The chart that I have referenced here on the board shows the various bends, 10, 15, 22 and a half, 30, and 45. It shows the shrinkage associated with those bends and the multiplier, which we'll talk about more in detail as we go. But basically the multiplier is what we use to determine where our second, third, and fourth bends are located on our pipe. And so you will notice a couple things. The smaller the degree of bend, the smaller shrinkage. And if you think about that, that kind of makes sense. As we begin to change the angle of that pipe, the smaller amount that we change it results in less shrinkage, but the multiplier actually goes up. And so what the multiplier again is where our second and our third degree or our third bends take place, and so they would be further out. And again, as those degree of bends goes up, our shrinkage also goes up, but our multiplier goes down. And again, this will be something that we will commit to memory, but we also can find almost all of this information on any of our conduit benders. And so it's something that's very easily referenced if we know where to look at. And then the last thing I want to cover in this introductory video would be what we call a stub take-up. The take-up itself is also printed on the conduit bender. And so again, this is not something that we necessarily have to remember. In this particular case, this is a 1/2 inch EMT bender. A 1/2 inch conduit has a take-up value of 5 inches. A 3/4 conduit bender or conduit has a take-up value of 6 inches. And then if we were bending 1 inch conduit, it has a take-up value of 8 inches. And again, those are all things that I will go into greater detail on some of our coming videos. Our next video in this series that our part 2 maybe would be the way to say it is going to demonstrate how to do a 90 degree or a stub 90 bend. And so I'll conclude by saying be on the lookout for that next video in the series explaining more in detail on how to perform a stub 90.